Hi everyone, my name is Andrea Gualandi, firmware engineer for Embit, and I'm going to present the latest LoRaWAN micromodule, EMB-LRWL55. This is the agenda that summarizes the topic we are going to address in this presentation. First of all, what's EMB-LRWL55? It's the new LoRaWAN OEM Embit module based on STM32WL55 system on a chip. This device is fully LoRaWAN compliant and can fulfill firmware and hardware requirements for both 868 EU and 915 US LoRaWAN regulations. This allows to manage both regions with one single part number, simplifying and optimizing the logistic. As you can see, the device has a really small form factor. Its size is comparable to 1 Eurocent coin and can fit a great variety of IoT use cases. Its performing hardware architecture, together with the availability of multiple firmware resources, enhances security, guaranteeing a strong protection for your applications. Now let's address the main hardware features of the device. First of all, the STM system on a chip is characterized by a powerful dual-core architecture, which embeds an ARM Cortex-M4 as a main core, corroborated by a secondary ARM M0 Plus processor. You will be able to connect any kind of sensors and actuators by means of multiple interfaces, such as SPI, I2C, low power UART, ADC, etc. etc. The power consumption management can fit strict requirements and provides a strong reliability. In fact, the device is able to operate in 8 different power modes, with consumptions that can be reduced down to 8 nanoamps. It is also characterized by generous memory resources, with 256 KB flash memory and a 64 KB SRAM. As previously stated, the STM32WL55 exhibits many security hardware modules to easily generate CRC, random numbers, and strong encryption keys. This allows to fulfill the needs of LoRaWAN and many other proprietary radio protocols. Firmware and data can be protected against read and write operations. Moreover, the dual-core architecture enhances the overall protections, since each core is equipped with an independent protection unit. Also, the computational resources provided by the secondary MCU core can also be exploited in order to provide further protection mechanisms. Now let's come to the radio. The device is equipped with a very versatile radio module, capable of covering the whole 1 sub-GHz band. Available radio modulation include not only LoRa, but also most of the typical and widespread ones, such as GFSK, GMSK, and BPSK. The RF is also characterized by a dual transmitter, which allows to independently reach 15 and 22 dBm. The EMB-LRWL55 comes with 2 options for the antenna, micro VFL and the ground signal ground configuration. The following represent one of the most interesting features of the module. The flexibility of the radio offers the possibility to meet the requirements of both LoRaWAN 868 MHz and 915 MHz regulations. That means that you will be able to deploy your IoT application, both in Europe and North America easily, with one single part number. This of course helps to simplify the logistic, reducing significantly the cost. What about firmware resources? The EMB-LRWL55 exploits a full LoRaWAN 1.0.3 compliant protocol stack, with implemented Class A, Class B, and Class C. The Embit approach is based on 2 separate solutions, the micro-embedded and the ABI. The first way to implement your idea is by exploiting the Embit SDK, which offers a set of firmware libraries to set up the network and manage the communication. The second option is the Embit binary interface. The ABI implements another layer over the LoRaWAN stack, which allows an external MCU unit to manage the module by means of a set of AT-like commands using UART or USB. Besides LoRaWAN stack, other Embit firmware stacks and protocols will be soon available for this module. This involves Embit 868 MHz wireless and bus stack and the Embit DALI firmware interface for smart lighting. Now, these are some of the typical use cases. The long-range communication provided by LoRa modulation that can easily cover kilometers in line of sight fulfills all the requirements for many smart agriculture applications. The intrinsic penetration of LoRa modulation, together with the security tools and mechanisms offered by the Embit device, can be exploited in any smart city and smart building scenario. Smart metering devices always require long battery lives, and the low consumption and flexible power management of the STM system on a chip are perfectly fitting these needs. To help speeding up the development of your idea, Embit offers the EMB-LRWL55 SoC. As you can see, you will be able to connect your sensors and devices exploiting multiple digital interfaces. The programming interface can be used to load and debug your firmware, while the USB connector can be used to send ABI commands. The board also embeds a temperature sensor, a reset button, and multiple GPIOs. The EMB-LRWL55 comes with all you need to start developing, including an 868 MHz antenna, cables, and a programmer. So this ends this presentation, but please have a look to the other contents on Embit YouTube channel and visit our Twitter and LinkedIn accounts. For any question or further information, send me an email at andrea.gualandi@embit.eu or info@embit.eu.